Hey guys, so for this problem here, we're gonna do problem number 10, okay? And problem number 10, it's like a not a continuation, but it's you can use the same kind of mindset of problem 9. And I did this part here just to show you to be quick here for you guys to not lose time. And so as you know, we have this container here, and we have a depth here where we're going to find points A, B, and C. Okay, and this container is filled out with oil, and we put here the density of this liquid, the oil, right? So the question is, what is the pressure at point A? Remember, this container is open to the atmosphere by this end here. Okay, so what we're gonna do, we're gonna use this formula here, right? Number one, formula number one. Do you remember that in problem number 9, the video before this one here, uh, we used the second one, right? Because it was going up. We were going up. We were going to a place where the pressure was less than the atmosphere, right? But here, we are going deep into the liquid. So we need to use this one here, okay? Because of the difference in height will be different than the other when we go up. So take a look. We have the pressure here in point A. That means this point here. And we need to calculate what is this pressure. So this pressure will be the pressure here. That means the initial pressure, the atmosphere pressure, plus the density of oil times gravity times the difference in depth between these 2 points. Well, we know that we have this difference here because it is in 50 centimeters. So the depth here from the atmosphere point is going to be 50 centimeters. That we need to change it. We need to change to 0.5 meters. So after that, we plug it in all the numbers. So for example, this guy here, this is our atmosphere pressure, pressure at the atmosphere, plus the density of the oil, gravity, and the height. Okay? So when we plug in all the numbers, we calculate everything, we can see that the pressure inside the oil was higher than outside. Remember, 101.3 times 10 third, this is going to be higher. And the letter B asks us, what is the pressure difference? Well, the pressure difference will be 4,655 pascals, or 4.6 times 10 3 pascal, or 4.6 kilopascals. Now, what is letter C? Take a look on letter C, guys. Letter C is asking us about what is the pressure between point A and B. Well, pressure between A and B, it's this depth here, right? So it's between these two guys. So we are in 25 centimeters, right? So this guy here, compare it with this position, right? But if we come from the surface to here, it will be 75. So my depth here will be 75 centimeters, or 0.75 meters. So what we need to do, we just need to plug it in this number into the same formula. So the pressure between A and B, it will be 101.3 times 10 3 pascal, plus the density of the oil, 950 kilograms per cubic meter, times 9.8 meters per second square, times 0.75. So if we let me use my hyper super calculator here. This will be 101.3 times 10 over 3, so it's going to be this number, plus 950 times 9.8 times 0.75. So the number will be 108 to a 2 times 10 a 3. No, not you don't. I don't need to put this one here. It's only later. So I don't need to put this guy here right now. So this is going to be 108 2,282 Pascal, or if you prefer, 108.3 kilopascal. Okay. So this was letter C. So that was the pressure between A and B. Now, what about letter D? Between points A and C. Well, between A and C is the same number than between A and B, because these two guys are at the same level. And we've learned that every time when we have a pressure inside the pipe here, all the height that are in the same level, that means they are in the same level inside the pipe, they will have the same pressure. Okay, so letter D, if we can write like this, so this is going to be the same pressure between both points. So the pressure between A and C will be equals to 108.3 kilopascal. Did you understand why? Because these two guys here, they are at the same depth, if we can say that, right? And A, we have the same pressure in the whole part of this height here, or this depth here. So the difference between these 2 points are the same here and here. Okay, so between these 2 points it's going to be 0.75 in depth. So this is why we have here that we can say that they have the same pressure in both points. Okay, so please let me know if you have any questions about this problem here. Guys, let's go and do some physics.